So, anyone recognize this photograph that's my virtual background?
Brooklyn Bridge?
Wrong end of the country. That's the Golden Gate Bridge.
Golden Gate Bridge.
Correct. Now, who can tell me what's wrong with the image? I'll give you a hint. This end of the bridge, this is the north end. So if that's the north end, to the right of the image should be west. But there's the San Francisco-Oakland Bay Bridge right there, which is east of the Golden Gate Bridge. So this image is flipped. This is the Pacific Ocean to the left. It should be to the right. Now I have some prior knowledge. I grew up there. In high school, I climbed to the Pacific side of that tower, which I found out years later was horribly illegal, and had I been caught, I'd still be in prison. So, good thing it wasn't for me. Okay, 1, 2, 3, 4, 5, 6. I think that's everybody that's going to be here live. So, good morning, and today's topic, we kind of hit on a lot on some of it yesterday, perhaps most of it. So today was supposed to be the ShareHYDRO primer, and we'll still do that. I'm not going to go the whole hour and a half. I'll stop when it seems appropriate. I'll also spend a little time today on introduction to the R scripting environment, because I think for some of you that's entirely new. It's a programming environment, and our intent for this semester is not to become programming experts, but to be able to manipulate things enough in it that it can be helpful for teaching us certain aspects of hydrology. So I don't think it's very hard, but that's unfair because I've been using it for almost 15 years. So I'll do my best to get things started off. If any of you have familiarity with Python from other classes, they're not identical, but you should find a lot of commonality. And so if you're okay with that, you shouldn't have any trouble with this scripting language. The main big difference, Python starts counting things at 0, R starts counting things at 1. That's the biggest thing you need to know. And then I also want to repeat moving files back and forth to the shared environment. So let's begin. So I'm going to share my screen. And now you should see my computer screen. And we're all off here to the right. And here's the learning management system as before. So I made some, based on yesterday's lesson, I made a couple changes into the links here. I actually have the direct links to the different environments along with the appropriate passwords. That was a good idea that came to me after one of y'all asked me the question on the password. And the reason I did that is you have to have credentials to get into this learning management system, so it's not like I'm throwing passwords out on the internet. So I'm quite comfortable with that. And so this works the same way. You can still go through the main website, but you'll have to remember the password at that point. And what else have I done? If you've logged into it recently, it seems like everything's due on the 9th. That's a mistake. Don't worry about that. The only due dates that are in force are in exercise set 1 and quiz 1. I'm still programming the class. So if you're not familiar with how learning management systems works from a instructor end of it, everything has to be programmed into the system. So your professors that use Blackboard, if they really use it, I mean, the Blackboard and Moodle have similar functionality. To do it really well, there's a lot of programming involved in every class, and unfortunately, it's not a matter of changing dates. Actually, that's a big part of it. Okay, so with that warning, don't have a coronary. when you see 100 things due on the 9th, because that's a mistake. So today is lesson 2, and it's only got 4 or 5 slides. And there's links to videos. I'm actually going to go to the lesson from the research. See if this works. Sweet. Okay, good. So that takes us straight to the lesson. That's what I mean by programming. I left a couple books on scripting in R. This is one that I wrote several years ago for a class, and it's now taking its sweet time to download. And the other one that's useful is a first course in R. I call this the OWL book. With this, you should be able to figure out how to stumble around in the R environment for the few exercises where that's required. I mainly use R as a tool to manipulate data files. So if the file's in one format, it's really easy to restructure it using this tool. Okay, and there is a pre-recorded video, and I will be posting the video of this Zoom presentation when we get to it. So let me download. And run the, see, 6 slides, the best one ever, and I'll still make this last an hour. So I've called this lesson Computational Hydrology for lack of a better name. And this photograph is in Utah in Zion National Park. I wish I could say I took it myself. I've been there. You don't want to be here when there's a flash flood because you'll have a hard time breathing unless you have gills. We're going to go over using the ShareHYDRO. For anyone who cares, DAAS means Desktop as a Service. Like I said, it's an experiment. Someday I'll be doing this on Amazon Web Services, but I've got to figure out how first. And then if you want to work on your own laptop, completely independent of this, that's fine. You'll want to install R, HEC-HMS, SWIM, and PEEK-FQ. And those are all readily available on the internet. Is anybody in the class a Macintosh user? So if you are, go ahead and I'm not trying to send John a private message. I clicked on something wrong. If you are, go ahead and acknowledge that because I'm using a Macintosh very poorly right now. Get my face out of here. Because I have application bundles that run these on a Macintosh. Unless you have the Catalina operating system installed, nothing works. Catalina was Apple's way to cost everybody thousands of dollars in software licenses that no longer work. Okay, that's enough of my rant. Let's continue. So what is computational hydrology? So it's the development and use of tools to simulate and investigate the terrestrial hydrological cycle. That's not how I talk, so I obviously copied that from somewhere. What we're interested in is to have an ability to simulate the interactions between various components of the hydrologic cycle, investigate the effects of climate change on the hydrologic cycle. In our case, since our main driving force is going to be the precipitation signal, I don't intend to spend much time in the atmospheric part of the hydrologic cycle other than stipulate that we get rain from it and we evaporate back to it. So the main investigation of climatic change is what happens if rainfall behavior changes. How does that affect things? Forecasting studies for drought and stream flow, and analyzing large data sets. So with any luck, we'll get to do all 4 of those things this class. So more about ShareHYDRO. We talked about it yesterday. It's an alternative to downloading and installing software on your machine. And I'm going to try to use it exclusively for the class because it will slow me down because of the network lag time. And it's unique in that you actually can run it entirely through a web browser. There's an important thing in this slide is these last words. Any work you do in ShareHYDRO resides on the remote server. So you have to remember if you do something that's important that you got to pull the files back to your local machine. And I have some notes here that I'm going to demonstrate that again today. There's 5 portals. More to be added is needed. That's a lie because I pretty much have burnt up the disk space on the server. And the web password is embedded in the Moodle site. So let's go ahead and demonstrate it. So we will go back to Moodle. Is it here? No, here. Hopefully it maintained my single sign-on. It did not. Sweet, it did. Okay, site home. Lesson 2. Oh, bad move. I want to go to the course content. So, which one do we want to play with today? I'm going to do 3 is different than the other ones in that the background color is different. And that was just an accident. Okay, so we will go ahead, I'll go ahead and log in, VNC pound, THREE. And I'm still amazed every time it works, so you didn't see me go, woohoo. Okay, so here's our shared environment. And I'm going to take some time on this today. So there's this folder here that's your home folder. The underlying operating system that this is using is Linux using the XFCE desktop, which is jargon. It's very much like a Windows and/or a Macintosh desktop. It's got a lot of similarities to both. In each of these, someone else on Hydro 3 because the mouse moved without me moving it. And so that's one of the risks. If there's 2 people connected at the same time, it won't break anything, but you may lose control of your mouse from time to time, and it's really, you think you're going crazy when in fact you're not. It's just somebody else has moved the mouse. In the future, years from now, I'll probably have this figured out so that everyone can have a unique environment. In the home folder is where a lot of materials are supposed to be kept. Well, it looks like Hydro 3 doesn't have any of the individual folders. So this was a good choice, completely by accident. So to create a new folder, you right-click on the mouse. I'm going to choose Create Folder, and I'm going to call this one R scripts, and I'm going to leave it on the desktop. And it should appear on the desktop, and it should be empty. We'll go ahead and we'll make an R script, and we will consider that it has a lock symbol on it. Oh, good, at least it worked. Okay, that's fine. So here is our desktop, and there's not much interesting in here. There's our scripts, okay. So I'm going to go ahead and see what working directory that it's in. We want to go to desktop, our scripts. Okay, so now we've set the working directory. Okay, so R is this interface. This portion here is called the console. There's another one called terminal and jobs, and I hardly ever make use of those, so I don't even know what they are. There's this environment tab, and over here is the files, and when we make plots, this plot tab active. So R was originally written to not have this interface. This interface came later. This is actually by a company that sells the RStudio interface. You can download this copy for free, but if you use the professional version, it costs money, and it's money well spent. What I find that I like to do with R is we can go to File. I'm going to create a new file, and I'm going to declare it's a scripting file. And it will leave a blank scripting file. Any command that you would normally enter in the console, you can enter in the scripting file and save it for later. So we'll start with, actually we'll start with a really dumb one. So I'm in the console part of the program. When I hit return, it's going to print back to the screen the words hello world, and I think it's going to do it in red. Ta-da. But that scripting activity is not saved. It happened once and it's gone. But if we put up here in this file, got to keep remembering I'm on a server and my key commands aren't going to work. I can copy that. I'll paste it up here. I'll save the file. Hello.r. Hopefully it puts the extension for me. Oh, it does. Good. Okay, so it automatically extends it for me. So now I've saved it. And let me clear the console. So my console is empty, and if I choose the word source, it's going to attempt to calculate the entire file. Or if I highlight a section and choose the word run, it will just run the highlighted section. I'm going to choose source, and it ran the whole file and produced the rather wonderful statement, hello world. So that's the beauty of R. If you're familiar with MATLAB or other scripting stuff, you've done this before. So let me modify hello world a little bit, and I want to make some plots. So instead of the equal sign, what it used for assignment is the this kind of arrow structure. So you do I guess that's a less than sign followed by a hyphen, and then I'm going to go ahead and create a vector of x. So I'm using the little C thing, which means to concatenate. So it's going to join the contents in the brackets as a vector. So I'm going to guess 0, 1, 2, 3, 4, 5. And I'm going to square x, and we'll plot that in a minute. Helps if I type the right keys. Okay, so I'm now returning to the console. As far as the scripting environment is concerned, X and Y don't exist yet. We can demonstrate that by, now if I run X, X exists. Y doesn't exist yet. Now if we run Y, Y should exist. Okay, so in these scripts, the RStudio development environment operates from the top down. So it's going to do the first statement, then the second one, then the third one. all the way down to the end. So later on, if you introduce functions, because one of the powerful things is you can create a function and then operate on the function. The functions have to appear before their use. It's called a prototype function in other programming constructs. So you'll see me use the words prototype when we get to that. So let's go ahead and plot x versus y, and I'm going to choose a type. S is a stair-step plot, so it's going to have kind of a jagged appearance. That's intentional. So right now there's no plot appearing. If I save the file, then run the source, it produces the plot. Well, we decide we don't like the stair-step plot, so let's change it to a line plot. The saving is a habit. I don't think you have to save to resource a file, but I'm not positive. And it's made a plot. Now suppose we don't like the color. We'll make it magenta. That's my favorite color for just fussing around because it reminds me of the Rocky Horror Picture Show. And make it a fat line. And there we go. So that's the R scripting environment. Now, there's no way I can actually feasibly go through an initial primer. As we're using this in different parts of the course, I'll try to slowly develop the various things in the environment. Let's say we want to save this file. So the file's already saved. We will save it by its same name. It's going to ask us if we want to replace it. And we do. Now suppose we want to get it back to our local machine. We have two options. The one I showed you yesterday, which is to run it through the Moodle site, which is probably the preferred option because you have the ability to drag and drop files. The other way is you do have a functioning web browser, so you can open a web browser and use the web interface to your regular email account and just mail yourself the file. I find that kind of asinine, so I would recommend using the Moodle methodology. So I'm going to go ahead and do that right now. And when it gives you this application thing, choose Firefox when you're on the ShareHYDRO environment. The links in the links text browser and the LYNX text browser, that is a text-only implementation of the World Wide Web circa about 1992. If you've never done that before, you'll find it incredibly hard to use. And the Chromium browser doesn't work terribly well on these environments. It's not a fault of Chromium, it's a fault of the person that built the environment, which would be me. But Firefox works the way we expect it to. And we'll let it load up. It will take a few seconds, even more with an audience. And this is a normal load. The operating system is called CentOS. And we want to go to our log in. Today I'm actually doing it as the admin user. And I suggest you don't save passwords, but it doesn't really matter. I'll go to, actually I'm going to go to Site Home, so I want to get it to the right class. Surface Hydrology. and then I use the private file thing. So the private file is unique to each of you. So if you move something to your private files, I can't see it. No one else in the class can see it. And we would go to our script directory. Grab the file. Hit save. Let it, I'm pretty sure it's there already. And now I'll go back to my local version. Go to those private files, and hello R is here. I'm going to pull it onto my desktop. There we go. Download. I'll open up my local copy. So this is on my laptop at home. And close these other things so I don't get all confused. And it ran locally. So that's that, in my opinion, is the best way to move files. Now, a comment on the types of files. When we get to the HEC-HMS tool, which is the hydrologic modeling system, that's created by the Army Corps of Engineers. Hence, it's got the most complicated file system in the history of the world. And instead of moving single files, you have to move their unit of modeling is called a project. You have to move entire project directories. The easiest way to do that is to move them as zip files or as tar files. So you compress the project directory, then you move the entire compressed directory, and then you decompress it at the other end. And zip and tar are both available on the remote server for decompressing, and I think zip files and tar files are built into most computer operating systems. In the case of swim, there's only two important files that you ever have to move in a swim model, which is the file with the extension .inp, which is the input file, and if you have background imagery, they're usually going to be in bitmaps .bmp. So that's only two files. You don't have to be compressing those. It's easy enough to remember to move two files. And let me disconnect from R. And you notice up here, at least on mine, the tab is still live, so we're still connected to the remote machine. I'm going to log out. That was stupid. I'll log back in a second. That'll be a exercise that we'll deal with in the near future. So kind of some foreshadowing there. I wanted to, let me find a HEC-HMS model on my laptop computer and demonstrate compressing the project and moving the entire project to the remote. I think HMS is the metafile extension. And naturally I don't have one, do I? That is hard to believe. There must be one on priceless. I'm looking for some HEC. Getting there. Well, I'm embarrassed of myself. I should have been a little bit better prepared for this part of the demonstration. And I would pull the example file that's already up there to my Macintosh and run it, except I don't have HEC-HMS on the Mac. I have thousands of it. Oh, there we go. We're getting somewhere. Okay, good. Here's an HMS file, and there is the meta file. So if we wanted to move this to the remote server, we would want to compress it. And my options are to use the Macintosh compression software. Hopefully it'll make a zip file will work. And now I want to go to my private files and upload a file. So choose file. Now I have to find the directory. Okay, process 4. And there's the zip file. That's the one I want to upload. Choose that. Actually, I'll just save it as it's. Upload it. That's scary fast. Okay, so now we want to go ahead and extract the file. So you're gonna have, like me also, we're gonna have to, when we're doing this, remember not to log off until we're actually done. And the password is that's odd. Looks like I never got there. Try that again. That's extremely annoying. Try that one more time. So it claims it's there. Now we go to this one, refresh the page. Yeah. So it's not perfect, but select the file, we'll download it, choose OK. And so on our program, we just brought this zip file. Now, unzipping it is a little tricky because if we double click on it and attempt to unzip, it's not going to have, there's no archive manager. But if we go to a terminal window, change directory to downloads, list the contents, it's there. Let's go ahead and unzip it. I think it's not going to have, there's no archive manager. But if we go to a terminal window, change directory to downloads, list the contents, it's there. Let's go ahead and unzip it. I think it's and now there's example 4a. So let's see if we got lucky and it worked. We will go ahead and launch HEC-HMS. Do some waiting. I'll go to Z, I think. Z, home. This is the hardest part, is finding your way through the file system. Downloads, example 4a. Hit convert and let it do its thing. So in theory, example 4a is not a very interesting example. We've just moved a file from one location to another, and let's see if it actually is going to work. Go ahead and make the run. Cool. And now if we want to look at output, we can. So that was moving a file from a laptop to the share environment. Let's say we make some change to it. So let's change the loss model, for instance. I gotta remember how to do that ahead of time. Maybe it goes here, loss method. Okay, so now we're going to make a substantial change, and then I have to go ahead and give it a curve number. I'm making numbers up. That's in Dallas, so that should be pretty good on that. Hit a save. So you can see we produce different output. And let's suppose we want to save all that. We can exit. And now example 4a on this server is different. And I'm not going to delete it. I'll move it to the desktop for the time being. And now if we want to send it back, we have to compress the file. And in my opinion, tar is easier for that. So tar So what this is going to do, it can take the contents of the example 4a directory, which we just extracted and made a change to, and it's going to save it in a file called ex4.tar. This part of the command means compress, the VV means double verification, and the F means force. So it will force everything into the tar file, and it tells us what it archived. And when we look here, there's now a tape archive file. So if we bring back our private file browser, cancel on that, go to the add, we will look for a file, and we want to look in home, downloads, there's the tar file, select it, hit the upload, save it. And the only thing I can't demonstrate is once I get it to the laptop, I don't have any way of running the file. So you're going to have to just trust me that it's a changed file. But we'll go ahead and complete that part of the simulation. It should be there. There's the tar file, and so now we can download it. We go to my downloads. We can see if the archive will actually work. Oh, cool. That doesn't always work. And we've now extracted it, and I'm pretty sure, let's see, we changed not sure we can see, it shows the changes that we just made, today at 9:41, and so on. Okay, so that's going to be the hardest part of using this remote environment, if you choose to, is moving files back and forth. The other important thing on the remote environment is those terminal commands. Those are using Linux commands in something called a bash environment, but there's not that many that you need to know how to do. And I will go slow, plus we have the video to demonstrate that. So to compress a collection of files, we use something called tar, which means tape archive. To decompress, if it's a zip file, we use the unzip command, and we have to use the terminal window to get to the correct directory. And if that becomes, for me, when that becomes problematic, I actually move the files to the desktop, and it's always open a terminal on the desktop, and then I don't have to worry about poking around looking for a directory. And so that concludes that. So swim would be handled in a similar fashion, and I don't think it would be necessary to demonstrate moving and running files in swim. It's done the same way, except it's a different program, of course. and that will be the main hard to remember activity. The only good thing is that if you forget, it's saved there on the server unless you destroy the file. So if something goes goofy and you forget, at least it's saved. So I wouldn't worry about losing anything. And that pretty much concludes what I had planned today for, another note. On the remote server, there's no word processing software installed. All your writing has to be done on your local laptop or desktop machine. So that's why the file moving is important. Any graphics that HEC or SWIM generates, there should be a, you can probably pull those graphics out using screen capture software on your laptop or desktop and put that into any report that you're going to write and then upload for doing homework assignments. That's all I had intended for today. Did I go slow enough? Do you have any questions? I'm going to stop the screen sharing and just, actually no, I guess I'll leave it up and active in case there's questions. So I'll open it up for questions, and if not, we can end the call. Anybody? Excellent. I'm doing a great job then. So as the course progresses, I guess I should verify that. Let's see if I can remember. I'm going to just. Okay, so when we get later on in the course, if you need to share your screen with the class, you'll have to tell me, and I can make any one of you all the host. And once you're host, then you can activate screen sharing and show the rest of us what's on your screen. So that will, when we get more interactive and later in the class, that'll come in pretty handy. If there is no more questions, I will go ahead and terminate the lesson for today. Okay, very good. Take a look at it. I have a server issue with lessons 1 and 2. It's not automatically grading them. So it has a summary thing. I won't be able to tell who looked at it, but once enough people have looked at them, I'll go ahead and I'll just assign hundreds for those 2 lessons for everybody. And I don't actually know why it did that, although those were created over a month ago, and I just added the other stuff recently. So I'm not so sure if it's something I did or if it's a flaw in the Moodle software. I doubt it's a flaw in the Moodle software. So I set something wrong, and I can't figure out how to unset it. But lessons 3 onward automatically record completion. So you shouldn't have to do anything except go through the lessons. And obviously there's blank lessons there that are placeholders that haven't been uploaded yet. So if you hit a blank one, I'm curious what happens. Won't let me add content if somebody completes it. So y'all could totally game the class by just running through all the lessons now and completely locking me out, and then I have to destroy them and start over again. Please don't do that. If there's no questions, I will see you all tomorrow, same time and channel. I'll be sending out the invite probably before 2 o'clock, and I will render this video and post it also probably before 2 o'clock. I have a question for you all. Any one of you can answer. Did the emails, they obviously got to you for the invitation. Did anybody go look at the video to verify that actually I sent you the correct link?
Yes, sir. I went and saw the video on YouTube. It was the correct link.
So okay. The reason I have to ask that is I'm posting those as they're called unlisted videos. So if you don't have the link, you're not going to find it by accident. And namely, that's because I disclosed passwords there, and I don't want my vast array of YouTube followers, all 35 of them, to go messing with your guys' work accounts until after the class is over. So thank you for checking that. I'm going to go ahead and terminate the call, and you all have a great afternoon. Goodbye.